Chapter 7, the moon. And of course, the moon and its intimate relationship with the tides on Earth. We'll get into that as well. All right, so the Earth's moon, of course, is its nearest neighbor, um, its nearest natural neighbor in space. Of course, there's lots of things in space orbiting the Earth, but that's all human created. Um, all the satellites I'm talking about. All right. It's, in the 1960s, we visited the moon. It was 1969, we actually landed on the moon, the United States, um, and we've explored the moon. That was actually a huge step to be able to go on the surface of the moon and bring back rocks and study the moon. All right, so we're gonna go through what we know about the moon, what we used to think about the moon, and all right. So the moon was born due to a collision. Actually, it turns out, as this chapter is going to develop, the moon is very different from the Earth in the sense that it's considered a dead world. Um, that doesn't mean it's completely inactive. There's really small moonquakes, really small. That that so it's not like the Earth. The Earth has constant tectonic activity. That is, the plates of the Earth are moving around. We don't even think the moon has any plates, and any volcanic activity. That was going on the moon stopped long ago. Like, literally, maybe it went on for about 1 billion years after the moon formed, but it's certainly not in the last 3.5 billion years since that time. There's no air at all on the moon. And we'll get into why that is. Of course, it just has to do with its small size. It's about a fourth the size of the Earth, and it's relatively small mass compared to that of the Earth. So it doesn't. It really, even if you had some air molecules trapped, briefly on the moon, they would easily reach escape velocity once they get exposed to the sunlight. Basically, as soon as sunlight hits some of these, if there were any air molecules on the moon, they would reach escape velocity very quickly. Right, the thermal energy from the sun would make them move much faster than the moon could hold on to them. Right. It's gravity which holds that. I guess that's something I mentioned. I should have said with chapter 6. The Earth, of course, we know it has an atmosphere, but it's really gravity that holds the atmosphere, and that's true for all the worlds that have atmospheres. Venus, Mars, some of the moons out there, other moons around other planets. We'll get to that later. All right. There was tremendous, lots and lots of impacts on the moon that can still be seen today. And of course, the moon is, we know that there's lunar eclipses and solar eclipses, and that comes from the fact that where the moon is currently, it's actually getting further from the Earth, as very slowly, mind you. Nothing to concern yourself with. It is, though, moving very slowly, slightly away from the Earth as time goes on. But it's going to take millions of years to get noticeably further from the Earth. All right. The only reason we know that is because we have we have these little reflectors on the surface of the Earth, the surface of the moon, and we bounce laser beams off of those little reflectors. I'll talk about that more later. And of course, the moon is the main thing that is, and it's not, but it's not the only thing. The sun is also responsible for the tides. But the moon, our moon, of course, is mostly responsible for the tides, but by about more than half of the well, yeah, much more than half actually. I'll explain that when we talk about neap tides and spring tides. All right, that's towards the end of the chapter. So, okay, there, of course, so the moon is about 1/4 the size of the Earth. And also, the gravitational acceleration on the surface of the Earth is only about 1/6. So, for example, a 200-pound person would feel as though, if they were standing on the moon, they would feel as though they weighed 33 pounds, approximately 33 pounds. And that's because of the small size of the moon and its relatively small, as I said before, its relatively small mass. There, of course, is one of the famous footprints. I think, I don't know which one this is, but, of course, Neil Armstrong was the first one. It might have been, this might be Neil Armstrong's footprint. That makes sense to take that picture. Now the moon, the other guy who landed on the moon with Neil Armstrong, Buzz Aldrin, made a comment, a very famous comment, that it was when he got to the moon and he looked out. He said it was magnificent desolation. It's a very famous quote from him, and basically what he meant is you get different shades of gray. You don't really get much color in any, if you're looking out over the moon. I mean, there are little things that have some color to them, but mostly it's pretty gray. Most of the surface of the moon is pretty gray. There's some rocks that are much, more like much darker than, like almost black colored rocks. And there's some that have a little bit of color to them as well. But like if you just look out at the moon, from the moon, it's just you see gray pretty much everywhere. Now, so this is part of this magnificent desolation. The moon is covered in craters. There are even craters inside of craters. We'll talk about that a little bit. All right, so there's mountainous areas. I mean, they're not mountains the way you think of mountains on the Earth, right? I think, they might go up maybe a few thousand feet, and that would be pushing it. That they're not that tall. I mean, they're what on the Earth we would call foothills. Okay, so the moon is divided into two main features. If you just go outside and you take a look at the moon, you look at the full moon, I should say, or even when at different phases of the moon, you can notice this. On the side that faces us, so let's decide that we use the proper language here. All right. So a long time ago, people talked about the dark side of the moon. Okay, that's incorrect to talk about that. All right. The reason is all sides of the moon get sunlight. It's just that we don't see the opposite side of the moon. We don't see the. In fact, we're going to call it the side that we can see from the Earth is called the near side, or the Earth side of the moon, and the opposite side, which used to be called the dark side, and that's not a correct way to. That's not a good use of terminology. We generally we call it the far side of the moon, and the far side of the moon, as I said, is illuminated. But there are actually different features on the far side than so the darker regions that you notice right away on the near side of the moon. These are called Maria, which is just Latin for sea. All right. So when people looked up at the moon long ago, before binoculars, before telescopes were invented, they saw these darker regions and they imagined that they were seas, and so it's like Latin or something for it is actually Latin, not or something. It's Latin for seas, and there's they have different names. There's one called uh, the Sea of Tranquility. So I don't know how to say it using Latin. Um, it's something like this. It's like Maris Tranquillicus or something like that. I don't know. Anyhow, that's and then the other region, the lighter colored regions, are called the highlands, and the highlands are generally and they're actually made of different stuff. The Maria tend to be made of basalt. The Maria, these dark regions, these are, and we're going to find out the reason for that. It has to do with lava. They're just made of lava that cooled long ago, um, and the highlands are made of this anthracite, which is, as it says here, it's a rock that's rich in calcium and aluminum silicates. All right. All right, and it it just appears lighter in color. Now the far side of the moon is actually lacking. It does not have a lot of Maria. I think there's like one, maybe two that you can that look like Maria. Um, but it's really the near side of the moon that has the Maria. Notice there's also giant impact craters. You can see this is a very famous one, Tycho. Even with a small pair of binoculars, Tycho is pretty fantastic to look at. Um, and then you can also see that there are these rays that extend from these impacts. And we'll talk a little bit more about that. But remember, that's one of the main reasons for the difference between the highlands and the Maria, are the makeup of the rocks that we find there. Maria again is just basalt, and then this anthracite is what make up the highlands. And the anthracite the anthracite is a little less dense. The basalt is a little bit more dense. This, like, kind of frozen lava is a good way to think of it. All right, so again, there's craters within craters, as you can see here. They're all over the moon. One of the main things, and see where it says it's very few volcanic craters. There we don't. Most of the craters that you see, the vast majority, are from things hitting the moon. All right. So remember, we talked before about, or I just mentioned just a little bit ago, that the moon has no atmosphere at all, and it's pretty much a dead world. So that there's no there's no plate tectonics to move around the surface or the crust of the moon, at least not much. And so when something hits the moon, that impact is there pretty much forever. I mean, not forever, but that for a long time. Just put it that way. So something hits, and something else hits, and something else hits, and that mark is there. It's there for a very long time. Well, now over billions of years, the craters will get a little softer in the and that's just due to the sunlight hitting it. That's what they mean by the softer views. Some of them are much more crisp looking, if you will. Those are more recent ones. All right, we'll continue.